Yo, what's up, what's up, what's up, what's up? Welcome back. Today we are looking at implementing zlib in Zig. And the question is why, and there's no good reason. The reasons are, I feel like I don't really understand the compression algorithm very well, and I would like to, and I don't understand Zig very well, and I would like to. So we can do both of those things at once, hit two birds, one stone, and like implement something that is zlib compatible, try to figure out how does compression work, how does decompression work, and see where we get to. So, I opened up this like zlib Wikipedia page, and they tell me, hey, there's this like deflate algorithm, and that's what they use for their compression. They tack some headers on to add some like extra metadata, but the actual compression is defined by this RFC. And we kind of like looked through it a little bit. I haven't read through the whole thing yet, but we kind of got to the point where there are these like this concept of like Huffman trees and Huffman coding. And so the idea there is one of the many ways, one of like the several, I guess I should say, schemes that are being used in this like zlib or deflate compression, decompression, is they have blocks of like Huffman coded data where the idea is if you have like a string with like a lot of A's and then like some B's and some C's and like maybe like one D, the idea is that like this should take less bits to store than this, and this should take less bits to store than this. And so they kind of like define this like tree of data where they go like, okay, so A is like the most frequent, and then maybe we're gonna have like B and how do they do this? Like B and C and D, maybe. There's like a tie break here, so this I don't think this really works out. Maybe this actually ends up being like A, B. It might end up being A, B, C, D. But let's just say that we had a simpler case where we had only A, B, and C to deal with. So this tree is like predefined, and you can then say, well, to get to A, I need to take one left, and to get to B, I need to take one right, then one left, and to get to C, I have to take one right, then one right. And so you can like define these codes and say A is 0, B is 1, 0, and C is 1, 1. And then when you see your A's, B's, and C's in your text and you write them out, you would if you were uncompressed, you would write like the character code for A, and then the character code for B, and then the character code for C. But instead, you can pack all of those into a single byte by saying, well, like, okay, we'll put a 0 in first, and then a 1, 0, and then a 1, 1. And this is less than 8 bits, so this all fits into one character. Simple. So yesterday we were looking at how do we create this Huffman tree, and it was pretty straightforward. It's just like you take you count how many characters there are of each, or how many of each character there are, and then you just build this tree node by node, and you say like, we'll take like the least frequent thing, put that in the tree, start like add up how many, like the combined frequency of these two, stick that back in, and we just like iteratively keep pulling things out until we have our tree. So we built our tree, and that's about as far as we got. So I think that if I run zig build run, hold on, let's get into our development environment. Give it a sec. Zig build run. We see that we have some sort of like paths and some nodes in our tree. So this is this. Let's see if we can find out what the string was. We are encoding A, B, 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 C, D, and we're seeing that, okay, so A has 1, he's like at the top level. B and C, B is at like the second level, and then we have like C and D at the third level. And so the plan of action for today is to try to like take this and turn it into something that can compress and decompress data. So we need to like make some abstraction that lets us write like bits instead of bytes to an output stream, right? So if we see like the letters like A, B, C, D, ASDF, A, B, C, D, we need to turn that, we need to be able to say, okay, I want to push the A, which is going to turn into like just like 1 bit of 0. And then I'm going to want to be able to push my B that's like 1 1, and then that's going to have to turn into like binary encoded either 1 1 0 or 0 1 1. I'm not really sure. And we're going to have to like be able to like push into like a stream of bits sequentially. Then we can like use that to like do conversion from text to like the Huffman coded thing, and then we need to figure out how to like read that data back. And I'm not really sure how like decoding works yet, but we'll have to figure that out as well. So that's the approximate plan of action. Approximate plan. Okay. So bit writer. How the hell does that work? I don't know yet. Let's figure it out. So I was reading in here, there's like the concept of if we are taking bits like 0B11, right? And we are pushing that into a byte. So say we're going to have like some like array, right? And this is going to have like, how do I say this? If you were to push data into an array byte by byte, you would probably do it by saying like, okay, here's like my first byte, here's my second byte, here's my third byte. And these are probably stored in memory, like lowest address first, right? So like the first thing that you want to read is the first thing in the file. But the question becomes like, if you're trying to break up this like first byte into several bits, say I just wanted to push one bit, does that get pushed in at the bottom or at the top? And what happens when we overflow, right? So if I push in like 0B1234 and then I push in 0B1234, that should probably get put in as an array of 0B1234, sure, right? But then like what happens now when I push in 0B2 or like 1 1? Should I guess probably what makes sense is like that 1 1 gets pushed at the end of this byte or the beginning of this byte, who knows which side, and then like the stuff that didn't fit gets pushed out the other side, so we get like a 1 2 sitting over here. And the standard does define that. So they say, what do they say? If you were to print out the compressed data as a sequence of bytes starting with the first byte at the right margin and proceeding to the left, so invert this, the most significant of each byte, you'll be able to parse the result from right to left with fixed width elements. So they're kind of saying like bits push into the byte bottom to top, I think. Right, so you have like, say where our array is 0xC, 0xB, 0xA, where A is the first byte. They're kind of saying that this gets turned into 0B134, or whatever the hex code for C is, like 0000. I'm going to use 1, 3, 2, and 1, because that's easier for me to handle. That's 0B0000, 0011, 0000, 0010. Okay, so they're kind of saying, as you... like the boundary between these two guys is like the most significant byte of the first thing turns into like is next to the least significant byte of the second thing. Which kind of makes it sound like as you're pushing in data, you should be like shifting to the left, I think. Right? Because if I were to push in, 101010 1010 and then push in 0B11, I think that would end up looking like, by their definition, 10 in the second byte and 0B1010 1011. I think. All of that to say, when we push stuff in, we are going to be shifting left. We're going to like shift our first byte to the left. Yeah, that sounds right. So, well, hold on. So, I shouldn't be talking about pushing things in this way. Because when you write to a normal array, you kind of put like the new thing on the right. So here, when we're pushing in new stuff, we're actually kind of pushing in on the left side, I guess, of this scheme. I don't know if anything that I just said makes any sense, but I think I understand it enough to start writing some code, and we can figure it out from there. We can maybe write some tests, and that'll give us some idea. While we're here, we also have to figure out how the fuck do we want to model this in Zig? So I imagine probably what makes sense is mirroring their like writer like concept at least a little bit. Which I don't know where to pull that up from, but here they have a function that takes in a context and they write some bytes, and then they have like then you can return, hey, I failed, or it was useless. We're going to be a little bit different because we're going to be having to say how many bits that we want to be pushing from the byte that we're writing. And probably we want to wrap any writer, right? Like, so they can write, if I remember correctly, they can write to like an array, or you can write to like a file, and those abstractions are like the same. So probably we want to wrap that abstraction in one of our own, and then we can say, okay, when for our unit tests, we can write to a buffer, or just like for whatever purposes you can write to a buffer, but you can also write to a file and read from a file if you want. Sure. Makes sense. Oh, what the fuck is this? This already exists. Oh, that takes all the fun out of it. Zig, why? Oh. Okay, I guess that kind of solves the problem for us. But that's kind of boring. I did want to explore this myself. So the question is, do we just do it anyways? I know it's there, but I wanted to try it. But we can at least see what their API was. So they say, hey, I'm going to write some bits, and I'm going to say how many bits we're going to write in. Sure. Okay, I think even though it exists, I still want to try it. I still want to try it because I think it's a fun Zig experiment. Okay, so our thing is going to have some sort of like underlying writer, and I don't know how to like define an interface here, so probably we're going to have like some sort of function, I think, pub function bit writer. And he is going to take in a writer who has some sort of type, and he's going to return a type. Is that how this, like, how Zig stuff works? Say we were to look at, like, their array list concept. So this guy, he takes in a type at comp time and returns a type. And then they generate a struct for that type, sure. So here I say comp time writer. And then what does this guy do? He returns a struct where the writer is just the writer that comes in. Maybe we say W here in capitals, because I think, or maybe writer like this. I think that's the convention, that they use capital letters for types and lowercase for non-typed variables. And sure, okay, that's somewhere to start. So let's just say that we wanted to, and then let's maybe give this guy a write function that takes in all of the arguments that a writer would use, just as like a way to test that we're doing this right. So writer has a write function that takes in self and then a bunch of bytes. Sure. So const self is this, and then we can write self as self, and bytes is const u8. And here I get kind of confused, because I would think here that copying the struct by value here is wrong. So I wonder if at this, does it return a pointer type? I don't want like Zig help, I just want like the documentation. Here we go. And let's look at their compiler built-ins. Returns the innermost struct, enum, or union that this function call is inside. This can be helpful for an anonymous struct that refers to itself. So how do I... This is used, its file scope returns reference to the struct that corresponds to the current file. I feel like I'm missing something. I do feel like I'm missing something. I guess maybe... let's go back to the standard library docs. Writer, zig, stdlib. At this is just the type no pointer. That makes sense. But then what I don't understand is why the write API is not taking in a pointer to self. That's kind of where I'm getting a little lost. But it could be that, like, if I have a... Let's try to, like, look for an example of someone that we can get a writer to. So, like, an array... Does a writer for an array exist? Surely I can, like, take an array. Surely I can do something like... do I have to comment all this out? Probably. And then here, I probably want to do something like, let's create some buffer. Which I think I can say, like, if I just want a bunch of zeros in a buffer, or maybe I want it to be undefined. Some stack garbage on a buffer of like 100 U8s or something. Is that how I do this? It's more like 100 U8, I think. I think this is the syntax for defining a buffer of 100 U8s. Then if I wanted to like write to this thing, there must be some way to get a writer around there. I'm assuming. I mean, I could be totally wrong and that could just not exist. But it would probably be in std.io. And then probably there is a writer around some buffer. Surely that exists. Fixed buffer stream, find byte writer, generic writer, multi-writer. Bit writer, buffered reader, any reader. Maybe, zig, writer to array. To slice. Nope. This isn't what I want. I'm assuming this exists, but it could just not. But I'm gonna look a little harder. I was looking at zig.guide earlier, and standard library had readers and writers. So they have, yeah. So an array list has a writer. Does like just like a normal slice have a writer? But this will give us something to look at. So let's start with, here we'll make an array list. Array, std array list in it with some allocator, which means that we kind of want this stuff again. And then we can say var writer is equal to buff writer. And then we can jump to definition here. No language server? Why? Why is there no language server? LSP info. It's there, okay. Main zig. LSP info. Okay, I don't understand why that wasn't there before, but that's fine. Why is jump to definition not working? Jump. Array list is working. Okay, that's fine. We'll jump to init here. No? Why not? Why high? Zig build run. Okay, so he's not compiling because init. Oh, because array list needs a type, of course. Of course. Okay, there we go. So then we can say like buff writer. And then hopefully I can jump to definition on this guy. And he's going to tell me what this thing is. So he creates a writer who has a context, and that's it. Interesting. And this is just a stood IO writer. And the writer calls this write function with the context. But how, like, this write function isn't defined. When he calls... Oh, probably this, does the writer here have a definition here? I see. So they're calling a stood IO writer with an append write function. I see. Okay. So then when I call writer.write, he takes in self by copy because all he's actually storing is a pointer to self. I see. So the writer API isn't implemented for like whatever structure that I'm trying to push data into. It's like an extra type that's kind of related to that type, if that makes sense. So back to our bit writer concept. Here we this bit writer would want to have a context that he is writing to. I guess the context is the underlying writer. But he'd also have, like... Let me think about how to phrase this. So say we're writing, like, bits into some writer. We need to store both the underlying writer as well as the current byte that we haven't finished, right? Because like as you're pushing more bits into this thing, you need to be updating it. And so our context, we actually probably need something that's like a structure that has an underlying writer as well as like current byte, which is like just a U8, as well as like how many bits we've written to this byte. Right? And then this needs to be referenced by another struct that's a writer that implements like the writer API, if I understand this correctly. So then calling this bit writer is kind of like fucking annoying, like not really what I want. Because then I have to like retrieve a writer from the writer. You lost me? Yeah, it's hard to I'm struggling to explain it. So let's go back to like say like completely outside of this like bit writer context. Let's say that I had like a struct file, right? Do you know there's std.io bit writer? Yeah, I discovered that just like right after we started the stream, but I still want to do the exercise because I think it's fun. So say we had some file structure, and he underneath him had, or we'll call it, maybe we wanted to call it like buff writer. How do I explain this? This guy is going to have some sort of like data inside him, right? Which in this language is like, say we have like just a thing that has like 100 bytes inside him. Oh, that's so fucking annoying. How do I turn that off again? That like fucking auto formatting. There we go. The way that it looks like this stuff works is that they have a pub function writer who takes in self and he returns a writer, like something that implements the writer API. This is, fuck. We'll call this buffer. So we have some buffer, and he has some data associated with him. And then, if we wanted to use the write API on him, we like return a writer that like references self, and that has the write API. So that's where I'm getting kind of lost here, is that I have like this outer structure that's like holding my data, and then another structure that like actually has the API to do writing. So in our scenario, it would be something like Here our like buff concept would be like we have some writer that we're wrapping. We have current byte, as well as how far into it we are. Byte progress. So this all goes inside some sort of function. And we have to like name this thing. And so maybe I'll call it bitwriter storage or something for now. I know that's like a bad name, but I just need to like, I need to get something on paper so that I can like, so that I can iterate and figure out what it should actually be called later. Okay. So this is a thing, he returns a type, and he returns this struct inside. Sure. Now, this thing that he returns has a function writer that takes in self by pointer and returns a bit writer. I think this is where it gets, this is what I saw in like the array list version of this, I think. Because, well, I guess like our bitwriter API doesn't have to have the same API as the write API. We could, this might all just get simpler if we return a bitwriter directly and his write API just takes himself in by pointer. That seems fine to me. Yeah, let's just do that. That seems way simpler, way simpler. So data is going to be like a U8 that we're writing, and the number of bits that we're going to say, how many bits of this data do we want to write? Yeah, that seems more reasonable. And then maybe data should be a slice of U8s, because like maybe we want to write more than 8 bits at a time, so maybe we want to write like a metric fuck ton, and then we can just do all that at once. Yeah. And so then we can kind of say, while num bits is greater than 8, we can just push the next byte into the data. So we can say like writer write data 0, the first thing in the data. And then can we reassign the data by saying like data is equal to data from 1 onwards? I don't really know how like ranges work in Zig, but I'm just kind of like imagining that that would be something we could do. And then at this point, num bits should be guaranteed to be less than 8 or equal to 8. So we maybe say, well, num bits is greater than or equal to 8. Now it's less than 8 for sure. And we take like the last piece of data and we put the bits that we want to write into the least significant bit. So current byte is equal to data and 1 shifted left by num bits minus 1. So this will give us like a mask of how many bits that we actually want to store. Then what? So we have some amount of progress into the current byte. So if current byte dot, if the byte progress, how many things we've pushed into it so far, if that's something like less than num bits minus self byte progress plus num bits is greater than 8. We have to do something. There's like some special case here. So can I just say like unimplemented, assert unimplemented std debug assert const std is equal to import std, and then can I say like std debug assert unimplemented? Let's see. Does that give me something? I at least want to get to the point where like we can try compiling this. Why is it not byte progress and not bit progress? I was thinking of it as how many bits we are into the byte, not how many, but bit progress would be how many bits are we in the byte. Like the, you know, they're kind of like, I think they're the same conceptually. It's just like a very slightly different angle that you'd be looking at it. Okay. Hey, back at coding, cool things I see. Just wondering, are you rewriting that xset compression lib that maintainer added backdoor malware to? I mean, that just happened to happen at the exact same time, which is pretty funny. I just wanted to do this for a while, and it was like on my to-do list, so I just started. And then somebody in stream told me, like, "Did you know about the xset backdoor?" I'm like, "Oh, that's kind of funny." Okay. Does this compile? Does this compile? No. Because I didn't write my return type here. So for now, we'll just say it's void. It will probably end up having an error. Self isn't defined, so we say const self is equal to and this. Not and, at this. And then use of undeclared writer, so that's self writer. Okay. And now we can try. You should keep the backdoor to make the rewrite proper. That's so funny. I like it. Okay, so now we should be able to say that I have like some writer. So let's say that we create an array list. Array list U8 with our allocator. And then let's say that we want to create some sort of bit writer around that buffer. So we can say var bit writer is equal to bit writer who takes in our buff writer as its thing. And then we should be able to do something like bit writer dot write, and let's just try writing some data. So let's say that we wanted to write like, you know, 1, 2, 3. And so let's say that that's 24 bits that we want to write. And let's just kind of see what happens there. Buff.writer, arguments of function being called at comp time must be known. Interesting. So this returns a writer. Oh, because this guy doesn't take in a type. We're trying to say, hey, I want to take in a full-on writer. Right, of course. So how does that work? So when we call like init with an allocator, this is an allocator here who is defined as what? He says, hey, I am a mem allocator. But mem allocator is like an interface, is it not? Like when I'm calling my like array list initializer, I'm calling it with like an allocator associated with my general purpose allocator. Oh, but the general purpose allocator returns an allocator which is a specific type. Ah. I see. So all of the different allocator interfaces return the same allocator structure. So in our model, then that kind of leans towards all of our bit writers should take in a type of writer. So this is like, So it's a std.io writer. But the std.io writer returns many types. That doesn't really work out. We can't do it the same way as the allocator init. So we need, like, this is kind of fucky-wucky. We kind of need to create, we create a type who has to have an init function. Yes. Okay, so we say, hey, we're going to be a wrapper around this writer, and we are going to take in that writer here. Yes. Okay. Who returns a self. Yeah. New to Zig, why not just do writer : writer? There's like some stuff going on here where Zig is using it has types as values. So to do generic programming, we write a function that returns a structure where the member writer is of type writer. And then we actually have to feed in the thing that's that type as well. So that's where I was getting a little lost before. And I'm not explaining it very well because I'm fucking lost. But we'll get there. So he has an init function. He takes in a writer, and then we return self with writer is equal to writer. And then we have to initialize the values of like current byte is equal to 0 and byte progress equals 0. But I think I saw somewhere that you can like assign default values here. So maybe it makes sense for us to only overload the writer when we do our initialization statement here. Seems reasonable so far. So now we go back to main, and if we wanted to make our writer, we would say, hey, our buff writer type is going to be around this. We'll say const writer type is our std array list u8 writer. And then we can construct our buff writer, our bit writer around that writer type. And then we initialize it with our buff writer. Okay. I think that all makes sense. I think. Expected type const u8 found struct blah blah blah. So how do I make like a const u8 runtime? Let's just try like ABC or something. And then here we have to do something like this. How do I make like arrays like just in line? Ah, I see. It's like I do this and then a U8 followed by a curly brace like this. Close. Array literal requires an address of operator to coerce the slice type. I don't get it. I think it'd be simpler to make a helper type like this. Curious. So fixed buffer stream, he takes in a buffer that is any type and returns a fixed buffer stream that returns. Ah! So this gets me around this fact that I had to define the writer type here. Because I can, like, this bit writer would still have, like, the same interface, but I would create a function that generates him based off of any type of writer. So you would have, like gen bit writer or something, and he would take in a buffer or a writer that is any type. And that returns a bit writer of type of writer. And then that just returns bit writer type of writer dot init writer. Is that right? And then here, instead of all of this, I just say, hey, could I say bit writer gen bit writer with buff writer? Jesus Christ, I'm gonna lose my mind. Okay, back to this like string literal, this like byte literal shit. Yes, but instead of gen bitwriter, you call it bitwriter. But if I'm generating, if I wouldn't call it bitwriter, right? Because that's like the struct that I'm returning is already called bitwriter. There's like some like double type thing here, right? So this guy isn't returning a type. He's returning an instance of the type. So it being lowercase, I think is correct. Right? In the same way that in this example, they have a lowercase thing that's generating. Oh, I see. I would just call it like bitwriter like this. I see. That seems like the convention I've seen. That makes sense. That makes sense. Okay, back to this, trying to write 1 byte at a time to the underlying writer. It would be something like, they're saying like I need to coerce it with an ampersand or something. And then this guy needs to be try, which means that this is failable, so I need to put an exclamation point here. Which means that over here, when I have to try as well to propagate the errors. And now value of usize, how much I wrote, is ignored. So I think I can just ignore that for now. I guess theoretically it might not actually write, but that's okay. And then I cannot assign to the constant data. So I need to say like, I'll call this input data, and then I'll say var data is equal to input data. And then hopefully that makes it so that, oh, I don't understand the types well enough. I don't know if this is gonna like end up like doing like a fuck ton of copies. Because I'm trying to like make sure that I'm like iterating over this thing. So maybe it makes sense for me to just call this data, and I will start with like an iterator at data idx is equal to 0, and then I'll just use data index everywhere. And then here I'll say data idx plus equals 1. Okay. Variable of type comp time int must be const or comp time. Why is this comp time? Oh, I need to give it an explicit fixed number type. Sure. Neat. Okay. Right, so these have to be assert false. And then here I just write unimplemented. And now we have something that fucking compiles. Hell yeah. Why don't you use the ZigLSP? I think I am using the ZigLSP, am I not? It's like auto-completing and stuff. Right? I have ZLS running. So I think I am. But I'm not really sure. You must be seeing some behavior that that's like not what you expect. So you're asking a question based off of some understanding that like we can try to address that. I just don't know what you're expecting to happen that's not happening. Okay, so if I run this, zig build run, he says, hey, index is out of bounds. So while numbits, oh, because I have to decrease numbits here as well. But I can't assign to a constant. That's so annoying. Can I have like my function arguments be mutable? Because I don't want to like, you don't. Function parameters are mutable by design. Because if you pass by value, it doesn't modify the initial value. But like, I'm taking in a fucking usize. Like, if you enable build on save, it will pass compiler errors. Oh yeah, I mean, I'm just not I don't want it to do that. I don't want it to build every time I hit save, because it's like most of the times I'm not expecting it to. I don't know. I guess I'll just call this fucking initial num bits. Or var. Oh, that's so annoying. Current num bits. Like, what am I supposed to name this now? I guess I'll call this like bits written. And then I do everywhere num bits minus bits written. That sucks. Num bits remaining, we'll call it, is equal to num bits. And then we just don't fucking use num bits anywhere. Remaining. Sure. And then here I have to say bits remaining. Oh, I know, I understand, like, shadowing variables, fucking sketchy and bad. I get that. But also, like, the ability to shadow variables and make it so that you can't use the, like, I would love to be able to call this bits remaining num bits and just say, you know what, we have this new mutable thing, num bits, and it's the same as the old thing, and I just want, like, the old thing to be unusable at this point onwards. But I can't do that, I guess, because I couldn't even, like, split out a new function that works that way, because the new function would have the same problem where the function arguments are immutable. So I just have to make sure that I'm like, okay, I have this num bits thing, but don't use it. Don't fucking use it. And, like, I get it, but I wish it didn't have to be that way. Okay. So now I'm hitting my assertion, I think, that says unimplemented. Nice. And that's at 50. So I guess we're going to have something like the case where bits remaining is 0. We can just continue. We can just return. We're done. And so now, hopefully, we don't crash when I try to do this, which is great, but we didn't free our memory, which is bad. So we have to say defer alloc destroy. And then so does that mean in the underlying assembly it keeps num bits on the stack? I'm not sure. I think that probably the optimized version would compile that out. I would think, but maybe not. Somebody posted a link. Why is fnomit bin so much faster to get the first compilation error? Oh, interesting. So there's like a fast version that I'm supposed to be using when I'm like smacking out compiler errors. Okay, what was I trying to do? Oh, right, I was fixing my deallocation. So here, when I should say defer buff just d init. And then we don't have any d init on our bit writer, so we're chilling. And so now this, alloc.destroy takes in something. Maybe I don't d init my allocator. I guess I probably don't. I probably don't, because it's just an interface around the GPA that I already d-initted. Okay, cool. Cool, so now we should be able to print out our buffer. Like this. And we should see ABC at the beginning of it. We can't format this. Oh, because it's a buff items is what we're supposed to print here. There we go. Okay. Sick. So at the very least, we've passed through the writer correctly, which is good. And so now we just have to handle the actual interesting part of this, which is like pushing in bits into it. So we have to do something like bits remaining minus byte progress. This is like the first push. We want to take in let var const first chunk size is going to be this. He doesn't like this for some reason. What's he complaining about? Oh, because it's self.byte progress. Okay. And what do we do there? We take like next byte is like data at data IDX. And we're going to like shift this by some amount. Next byte shifted right by... Let me think about what I'm actually trying to do. Let's say it in English first instead of just fucking typing because I don't really know what I'm doing. We're trying to say there is some amount of data that will fit in the current byte. Sure. We want to mask off the lower end bits of the input data and put it into the upper end bits of current byte before writing it to the output. I think. So if we had like, you know, a byte that had currently been populated with 0B11, for example, and we want to push in, maybe we want to say like 1, 2, 3, 4. Say we had 6 bits written into our byte, and we're pushing in 3 more. So first we want to take 2 of these guys, put them in here, then write that byte out into the writer, and then start caching our next byte like this. So there's something about 2 here, right? That's how much we're going to be able to fit before pushing in. Wouldn't the byte be empty since all the previously written bytes are full bytes? Oh, fuck, yeah, you're right. This should actually be done before any of this, huh? This is assuming that, like, our write is aligned, which it's not, necessarily. So all of this things that we already did is wrong. So, sick. Super cool. I was watching the VOD from yesterday. How are you enjoying Zig so far? I think I'm gonna really like it. That's what I suspect. I can imagine it filling in this niche where I would have written C++, I can imagine Zig taking over there. But then it's like kind of like Rust already kind of fills that niche. So there's kind of like, they're competing in some way. But I can imagine it as like, if I wanted C with generics, but still simple, I feel like Zig is going to cover that very well. Where if I wanted like C++ and more complex but more restrictive, then like Rust seems like it kind of fills that side of things. So we'll see. I think I'm going to really like it, but, you know, right now I'm just struggling to do anything, so we will see. Okay. Let's think about this again. So all of this stuff I'm pretty sure was wrong because there's no guarantee that the data that is getting input is aligned. If it is, then that's great. We could do that as an optimization, but we'll deal with that. We'll think about optimizations later. Okay, so we're going to be actually looping over all of the data. And we are going to be extracting some amount of data at a time. Maybe for now we simplify this. I wonder if this gets simpler, if we kind of limit the number of bits that we can write at any given time to 8. Maybe it makes more sense to start there and then expand up to the more complex case later. And then we can start thinking about it like this again. There is some amount of data that will fit into the current byte. We mask off the lower end bits of the input data, and we put that into the upper end bits of the current byte. Okay, sure. So we have like first chunk size is equal to the number of the number of bits that we want. Okay, this is how much will fit. 8 minus the byte progress. That's how much will fit. That makes sense. And how much we want to push is the minimum of that and the number of bits that we want to push in. I don't know if there's like a min function. Surely there is. Like, is it a built-in? At min? Yeah, it is. So we take the minimum of this and num bits. Okay. That's therefore you just need to keep track of the bit progress rather than the byte progress, and it'll be much easier. Oh, I could see that. I could see that. Okay. So now what? So this is going to be like in our case here. Say we're trying to push in 3 things and there's already 6 things in there. This is going to be 2. So our first chunk mask is going to be 1 shifted left by first chunk size minus 1. We can apply that mask to the data. And then we shift this left by the byte progress. And OR that in. That might be right. So let's think about this as, say, in this case, our byte progress is going to be 0, 1, 2, 3, 4, 5. Looks like you're already using byte progress as bit progress. Yeah, I'm calling byte progress how far into the byte we are, which is very like the same concept of how many bits have we progressed through. But I can see the confusion. It's ambiguous for sure. Okay. So now, at this point, if we need to increment byte progress by first chunk size. Yeah. Okay. And then if self byte progress is equal to 8, then we push the byte. So self writer write the current byte. And then we can shift the data by the input data by how much we wrote, and then do it again. Oh, so you have a buffer in the current byte, and the byte progress keeps track of how many bits in that byte are full. Yeah, exactly. Okay. I think this is making sense. I think this makes sense. I think that we're very close to this working in a loop. Maybe. I don't fucking know. I would be interested in learning how Zig unit tests work here. I think that probably makes a lot of sense. Right, we can write a test to try shoving some shit in there and just see how it behaves. So it's just a test keyword. Is it like in Rust where I put like a module that's compiled out, or like what if I have like helper functions that I only want to be used in unit tests? Zig test. Okay, so I just write test, blah, blah, blah. Can I like Zig testing helper function? How to test multiple files? No, I want to like Zig compile function only for testing. Like, is that a thing that exists? Zig has lazy analysis, so test helpers won't make it into exe. Ah, nice. Very cool. Okay. It would be nice to like segment them still somehow, but it's okay. It's fine. So I want to do something like test non-overflowing right or something. I don't know. Test first byte. So we can do something that's very similar here, where we take some buffer and we want to use, I think I saw somewhere there's like a testing allocator that we probably want to use. Testing allocator Zig. And then there's some expect stuff. I could have sworn that I saw a testing allocator. Maybe it was when I got to file system. I think it said testing, stood testing allocator. Okay. So here I can use stood testing allocator. And then here I construct my bit writer and I just write in A and I write 8 bits. And so now I want to assert, I guess it's like, they said something about testing expect somewhere. Is that like in the standard library, stood testing expect? Yeah. So here I want to expect that my buff items is equal to, like, is this how I create an array on the fly? Oh, I guess I can just say A like this. Cannot compare strings with equals equals. Zig compare slices. Is it just like at memcomp or something? Compare arrays. There we go. Stood mem equal. All right. And what does this do? Compares two slices and returns whether or not they're equal. So here I have to put in his type, it seemed like. Comp time t. Okay. Zig build test. And then can I try expect false to make sure that my tests are failing? They're not running. So why the fuck not? Probably because my build.zig has to define that as one of my test files. It has a root source file in source main, and main includes this, so I don't really know why it wouldn't work. Zig test not running. Running test blah blah blah. So I probably, if I run like zig test source test bit writer, that runs it. Oh, maybe because the build is failing, it's not running the test step isn't running or something. So here, if I said that I want to write the letter A with 8 bits, now we're failing to compile our bit writer because he doesn't like the shifted left by first chunk size because it needs to be fixed with integer. Left-hand side of shift must be fixed with integer type. Oh, I see. So I need to say const. Can I say like How do I force this thing to be a U8? U8 literal zig. Can I like as nice. Man, you guys are saving me so much time. This is so much more fun when you guys can just tell me how to use the language instead of me having to Google it. So here I say as U8 1. And expected a U3, found a U8? Why is it expecting U3? Oh, what the fuck? That's sick. Wait, that's crazy. So here, they're saying that because a U8 can only be shifted by 3 bits, they're saying use the fucking 3-bit type. Holy, that's fucked. So here I can say as U3, and hopefully, I think probably that will... oops, I fucked up the bracketing here. Wait, did I? Can I do like as U3 this? Expected type U3 found U8. Why? Okay, also, this actually can't be as U8. This has to be as U16. So can I say, like, U16 here? Then I shift this left by some amount, then I subtract 1, and then it will fit in a U8. I'm pretty sure that's how this works. So this is where I don't... 4-bit int cannot represent all values of an 8-bit value. Oh, sure. But then, like... Oh, I need to dyn cast values, so I need to use int cast here. There we go. Nice. And then current byte instruct writer does not exist. Why? Why does current byte not exist? Current... Oh, because there's only one R. Okay, and then self byte progress is expected to be a... So here I do it int cast again. Expected type of U8, found U16. So then I can cast this back to a U8. Now that it's -1. But it's like, hey, I can't be sure of that, so I do int cast again. Int cast must have a known type, so here, first chunk mask needs to be a U8. And error is ignored on self-writer write. And I have to say, I don't fucking care how much you actually wrote out. Okay, hell yeah. Okay, and so now can I do zig build test? It's still not running my tests. Zig test? Zig test expects a zig source file argument. Zig test source. Okay, so I can run the test here. Writer write byte exists too. Oh, nice. I like that better. That's a nicer way to do this. Okay, so now I'm asserting false here, which is great. Okay, so all of my tests passing. So if I write a single byte, we are chilling. And now let's try writing like 2 smaller segments of a byte. So let's say I want to write A and 0B 00 1 2 3 4 5 6, and I want to say I want to write 6 bits from this. And then I want to... I guess I could just say, write 6 bits from this, A. And then write 2 bits from A shifted to the right by 6. I should leave this test here. And we can do it full byte as our first example. Then we'll do 2 smaller bytes, two byte segments. And I guess I don't need to use underscores here. I'm just kind of used to that. So here I want to write 6 bits from A. And those are the lower bits. And then I want to write 2 bits from A shifted right by 6. And then I should still expect an A here. No way did that work. Holy! Okay. That's surprising. Okay, now let's do something a little crazy. Let's now... We need to say, I want like an unfinished segment. Unfinished byte. And so the idea is when we finish this guy, we need to make sure that anything that's like in our last byte gets like flushed out. So maybe we'll call it flush. And just on flush, maybe we'll call it finish. D in it. I think D in it might be what people say. Then my writer has to have the last byte written. And I don't really like the idea that this could, like, what if somebody calls D in it and then keeps going? Like, maybe there should be like a validity check on all future writes. This should invalidate the writer somehow. Or is it the Zig way to just say, hey, if you fucking call D in it and then try to do more, fuck you. Like, is that the Zig way? Or maybe the Zig way is to only, there's like safe mode and unsafe mode. So maybe the Zig way would be to have some sort of constructor parameter that is like compile time defined to use the finished byte, like have a finish check, but only in safe mode, and then compile it out in unsafe mode. That seems kind of ziggy from like the one file I've looked at so far. But sure, whatever. We'll just do this for now. So all of these guys. Also, is there a way to fucking like force the D in it call? Like, is there like a flush sounds correct in that case? My problem with flush is that it kind of implies that you could call it twice. So my problem is that if I wrote like write like 3 bits from the number 3 or something, and then I called flush, right? And then I wrote 3 more bits, there would be like 5 zeros in between these two things. Which would not be what you would expect, I think. I think what you would expect is that when you flush, it like writes it out to disk, but the bit writer state stays the same, which isn't what we're doing. Finalize or finish IMO. Flush is fine, just reset the current byte var. But the problem is that we've pushed something into the writer. So if we're like 5 bits in, then there's going to be 3 unfinished bits in that have made it to the writer that we will never edit again. I like the idea of calling it finish. That seems fine. And I think somebody in chat said there's no way to force a defer call. Or like warn if not deferred. Zig. Zig force warning on missing No, that's a big point of contention. Okay, sure. I mean, I could see the argument for it not being there, and I can see the argument for it being there, right? It would be nice if I could mark on my type, like, hey, you should fucking call this, but, like, I get it. Okay, sure. So I just have to remember to call finish. So defer, finish. I'd love to annotate that method required. Yeah, that's kind of what I was thinking. But yeah, I can see it. I can see why it's a problem. Okay. So I guess maybe all of these tests end up in a block with defer BW finish. Uh-huh. So the finish shouldn't fuck up the other things, but in this case now, if I write, you know, like the number 1, I write 1 bit of 1. At this point, I do not expect anything to be in the array. So this I kind of expect it to be like, was it this? I know I've asked this like so many fucking times. What's my, like, the syntax for declaring an array? Zig inline array syntax. That's an inferred slice. Is that what I want here? That feels like what I want here, an inferred slice. And then here I want it to be like 1. After the flush, I want it to be 1. So here I can say like, expect the single bit to only have been written after finishing. Okay, error is ignored because that's right, because finish could fail. So defer, try, finish, but try is not allowed in defer expression. So how the fuck am I supposed to do that? I guess just on finish, I have to discard the error? Or I just manually call finish at the bottom. Just don't use defer then no. Yeah, I guess so. I guess so. Sure, I can see the argument there. And then these guys don't even have to be in a block anymore. Sure. Okay. Yeah, I'll take it. Zig build format. Zig format source. There you go. Ooh, Teresa. Whatever is syntax highlighting there did not like whatever I just did. How do I go back? Oh no, it's just fully stuck fucked. Okay. Let's just double check that my test is running. So I put a thing in there. It's not working. Zig build. Zig build test. Why is this not failing? What the fuck is going on? The reason it's not testing your bitrate thing is because it's not referenced in the main file, but it is referenced in the main file. Here I am creating a bitrate here and writing to it. So I think there's something else happening here. But not when it's building for test. Oh, okay. Interesting. So I'm just supposed to write, but if you guys are saying write zig test, but writing zig test doesn't do anything. Because like I want it like to test the whole project. In main, you have to add a test block which references bitwriter. Surely that's not the way, right? Am I supposed to like zig test whole project build zig? Like what am I supposed to be doing? Oh, interesting. So they're saying that I create a test block and reference everything. Oh, that's interesting. Is this like the Zig way? Is this what people do? I mean, Zig testing has a function called ref all decals. I'm gonna copy paste what this guy did because it doesn't seem insane. He's just saying like, hey, in a test, and I guess this Zig, we'll see. He doesn't like that. Unfinished byte. Oh, it failed. Oh, good. Okay, okay. Sure. Oh my god. The fucking syntax highlighting was gonna make me lose my mind. So, test full byte test didn't work. He's saying it here at line 74. This is not correct. So what is it? I think somebody said there was like, stood testing expect equal slices. Is it writing 0x80? It could be. Because this should be if self byte progress is greater than 0. Then I write. Otherwise I do not. And here, when I write it, I need to set the byte progress back to 0. There we go. Maybe that's it. Zig build test. And it's actually super undefined if these are actually running. So, okay, yeah, it looks like all of these tests are passing now. And so now let's do a test where we push multiple bytes. So we can do something like, it's going to be very similar. But let's push in like A, B, C. And maybe not expect ABC. And we make it fail first. Yeah, okay. Does kind of look like this is working as expected. Sure. Okay. Maybe that's good enough. You could do this in a loop as well, but maybe I'm just not going to bother with that for now. Okay. So let's say that we wanted... The nice thing about the expect equals blah 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 helpers is that they will log the actual values. Yeah, that makes sense. That makes sense. Does the writer and bit writer have anything to do with file output? Does it work with memory? I think if I've done this correctly, it should be able to write to either an array or file. I think. I wonder if is there anything that I'm missing like a test for in terms of like edge like bit boundaries here, since I'm always kind of writing these in chunks of 8. I don't know if that's like fucking stuff up. Like maybe it would be nice for me to write something over a boundary. Like, can I do something like this? I don't really know if that's going to work out. So maybe we'll do something like try write. We'll instead of using letters, we'll like kind of handcraft something that makes more sense. So if we do like write 0x0f and write 6 bits from that, then we know that the state of the writer should be 0xf. Then we can write in like 2 bits of 0b or 3 bits of 0b111. And this should now be like 1 bit should have overflowed into the next byte. And so now if we write 3 more bits, we should be at a boundary of 4. Maybe we'll do like 101 here so that it like kind of lines up. And then let's write in like 8 more bits or something. There. That should be like really pushing our like edge cases. So this is 6, 7, 8, 9, 10, 11, 12, plus 8 is 20. And so now this should end up looking more like the bottom. The first thing we wrote should be 1 1 0 0 1 1 1 1, I think. Then the next bit should be oh my god. It hurts. My head hurts so fucking much. It hurts so much. The bottom 2 bits should be 1 1, then it should be no, it should be 1, and then 101, and then D. Great. We'll write bits here. Okay. So now I can expect the bottom for 0101 here, and then the next thing should be 1010. I think. This feels maybe correct. And that test doesn't work, and I don't know. There's so much that I don't understand about why it's wrong, though. So it could be that the test is invalid. It could be that the actual functionality is wrong. Who fucking knows? So let's start with the simple case. We have 0xf. This should be 1111 over here. I should fucking just write this in binary. Okay. Chilling. Now, we push in 3 more bits. So now this should be 1 1 0 0 as followed by 0b1. That's not working, which is interesting. So now we should fall back onto those testing helpers. So it's like stood testing expect equal slices, who takes in same parameters, except it's not supposed to be expect, it's just, well, okay. So he's saying that the lengths are not the same. So expected this output, length 1, instead found this length 2. Oh, so I've got the front and backwards, it's this way. So now I'm expecting length 2, CF01, and I just got something that's length 1. So that's where it's interesting here. So the first byte, we run in, we write, and we say, hey, current byte, he's going to be ORed equaled with 6 bits. My byte progress should be 6. My first chunk size should be 6. No, because I took the minimum of our current byte progress and the number of bits, which is just fucking wrong. Is it maximum here? Let's think about this. So, oh, no. The minimum of 8 minus. So 8 minus byte progress should be 8, and then num bits is 6. So we should take 6 here. Then we like OR in the 6 bits, and the byte progress is now 6. Oh, we don't handle the overflow. We don't handle the second half. So the second byte, second chunk size is if num right. So here we need to handle the fact that we have written first chunk size bits out of num bits. So if num bits is equal to first chunk size, there's nothing left to do. But if it's not, then we have the second chunk size is equal to num bits minus first chunk size. Yes, okay. And so now we do something like second chunk mask is going to be, I think, the same thing here. Second chunk mask is this guy, but the second chunk size, which fix me factor out a function. Okay. Now we are going to say self current byte equals data shifted right by first chunk size ANDed with the second chunk mask, I think. And self byte progress is going to equal the second chunk size. And then if this is 0, the mask will be 0 and it'll be fine. Everything just works for free. This has to be int cast like this. And whoa. Oh, the second chunk size has to be a U8. Which means that this has to be int cast, I guess. Which kind of means that this num bits should be just probably a U8 from the get-go. Like, we can't really put in, like, a fuck ton. Okay, now, integer cast truncated bits. Interesting. How is that possible? This is at line 51. Hey, people often say that learning C is a good way to understand how computers work. Do you think languages like Zin and Odin could be options for that purpose? Okay, so we're gonna say that I'm struggling a little bit with Zig still. We haven't really quite got there yet. So there's like this really strong bias in my head where I understand C and I don't understand Zig very well, which means that like in my head C is easier. I don't know if that's true, but I do at this point feel like there's more to deal with in Zig, and that could be more difficult. Like the idea of using C as a way to like just get it, it feels like you couldn't get closer to like assembly without it just being assembly. I could be wrong there, but I've never even heard of Odin, so I can't comment on that. I would probably learn C before learning Zig at this point, but maybe I'll feel differently in a year. Like, who knows? So he doesn't like this truncation. I guess can I stood debug print can I print the first chunk size? Will that give me a clue? So first, do I not get my prints in the panic? That sucks. Zig stood out during tests or something. Zig testing library uses the progress utility, blah, blah, blah. So if I stood log warn, this will generate a lot of content without a new line. Oh, do I need to write a new line? Is that what this is saying? I should fucking finish reading, but I don't want to. You can't make me. I guess I should. Can I run GDB here? Is that what I'm supposed to do in this case? Maybe. Zig build test. So this is going to generate some test binary. Which is this, I guess. Yep, and then I can call GDB on this. Okay, and so then I can look at frame 8. And this is trying to write the byte. Oh, interesting. So can I go down? Self current byte is equal to this. So here we go. Now I can look at this. So we can print first chunk size, which is 8. We can print... Oh! I see, because 8 doesn't fit. I can't shift right by 8 because that doesn't fit into U3. So I need to actually handle that case. So I say if first chunk size is equal to 8, we actually have to return early here. Zig build test. Okay. So now I don't know how many of my tests are failing. 2 byte segments is failing as well as test multiple bytes. Okay. And then here, I guess we want to go back to using std testing expect equal slices. Because that will give us a clue on the failure, probably. And then they actually want it the other way. So here we expected A and we found nothing, which is interesting. So here we write the 6, then the 2. So I guess maybe we just fucking breakpoint here. Maybe. Then we run, and then we hit next, and then can we print BW? And we have current byte 0, byte progress is 0, so that's not expected because we wrote sum of A. Unless... yeah, that's supposed to write something. Okay. So what do we do now? I guess we run it again. Step now. And we can kind of just step through. So we said first chunk mask is... Can we print it as maybe binary? As hex? So 3F, that's 4, 5, 6. That makes sense. Can we print data? A? Yep. What's byte progress? 0? Okay. So after all of this, I can't imagine that current byte doesn't have what we want. It does have what we want. Okay. So where is it getting reset? This is here. So self byte progress is equal to 8. It's not? Okay. So why did it say that we ran this code? Well, we didn't. Okay. Oh, I see what it is. I see the problem. I see the bug. I see the bug. I see the bug. It's self current byte is equal to this. This is assuming that we push the first byte, but we didn't necessarily. So here we actually just have to OR this stuff in. And this has to be plus equals. Just in case we didn't. This is handling the case where the second chunk size is 0. We have to make sure that that doesn't change any state. Okay. Okay. So now everything seems to be passing, or they're not running, which is a fucking annoying problem to be having. I wish I didn't have to think about this. But let's just kind of make sure that we think this test is failing. Nice, okay. So we're chilling. And now we can go back to trying to push more. So now we push the 101, which should make this 101. Nice. And then we push the next 8 bits. And then this comes in as 0101. And the next bit gets pushed in as 1010. Boom! Hell yeah, baby! Damn. Okay, so that was fucking difficult. And I think most of that wasn't Zig being difficult, but me being dumb. I think that was most of it. Maybe some of it is related to unfamiliarity with the language. But I think we did get to the point where I'm happy with our ability to push bits into a writer that we wrapped, which is pretty cool. Pretty cool. So what did we cover? What did we learn? We learned how to write like a generic type here that wraps some interface. But by interface, I kind of mean like in the C++ template style of interface, where it's like this could take in any type that has a write byte function, any type. And then we made this function that takes in a writer of any type. I don't know how much I like this duck typing, but I get why it is the way it is. And that constructs a bit writer of this type. We return it, and then we have this like cool thing that we can work with. Okay. I will say, like, the Zig style generics, I'm pretty sure they feel better than C++. I'm pretty sure. I'll get a better feel for it as we go, but it's hard because part of me is like was really struggling with just writing this, but I can see how with familiarity that will be better. Can you just Zig build test summary? Not doing what I thought. Maybe I have to put like some extra double dashes. It does say that there's like a summary here. Oh, may I have to write summary all? Yeah, nice. Summary all. Yeah, that did something. I don't really know. Test cached? Seems crazy. Oh, 3 of 3 steps is here. Yeah, I'm not really sure. Not really sure. We're gonna have to. I'll have to look into this a little bit more off stream. But what else? We got into like Zig testing. I do feel like probably I think I'm probably happy with Zig test source bitwriter. That I feel like is making a lot of sense to me. That like just runs the file. I'm less happy with Zig build test because of the fact that there's like this like lazy initialization shit where main has to import everything that we are referencing in order for the test to run because of the lazy compilation, which again makes sense. Lazy compilation makes a ton of sense, but in this context, it's something to take in. But if you were to compare this with unit testing in C and C++, miles better. It's built into the fucking language. So pretty cool, pretty cool. Yeah, okay. I'm gonna call it there because we're at an hour 45, and I expected that to take like 30 minutes, and it took the whole fucking stream. So, pretty cool, pretty happy. Wish I got more done, but we learned a lot. Well, maybe you guys didn't. I learned a lot. So thanks for watching. If you like what you saw, we're streaming most days at around 2 o'clock Pacific time for around 2 hours. So if you're online between 2 and 4 Pacific time, you could swing by and see what we're doing. Right now, we're working on learning Zig and this like zlib implementation. So we're learning about like deflate and Zig kind of at the same time. If you're looking at like previous projects, there's a bunch of Rust stuff like operating systems. There's like some like web dev. There's some neural networks in Python. There's some like virtual file systems with Fuse. Just like lots of like that kind of stuff on like the YouTube channel, which is linked in the Twitch description, as well as the GitHub linked in the Twitch description. If you don't see the links on Twitch, which some people have been complaining about, it's the same as my Twitch username on both. I think that's it for now. Thanks for watching, guys, and I'll catch you on the next one. Bye!